Hello, and welcome to our webinar on mentoring, a really important and often unexpressed element of what is pretty necessary to bring teachers into the comfort zone of actually using system dynamics and systems thinking in their classrooms. We are going to have three presentations, and as before, we will have the presentations first, one right after the other, and then we will have conversation for as long as we need conversation. This way, those of you who can only stay 1 hour will be able to definitely see all the presentations, and then we will have the conversations and asking questions. So please, as your questions come up, as you're watching a presentation, please record your question on paper so that you can ask it later. Our first speakers are Dr. Meltem Alibioglu, who is a new PhD, and we're so happy to have her here. She has done a lot of work. She is a middle school administrator and researcher and does so much to support systems thinking and system dynamic in the school that she works with, and she teaches also some university classes. And her co-speaker is Emre Göktepe, and most of you know him because he does everything with the Systems Thinking Association in Turkey. And they will talk primarily, I believe, about the middle school mentoring. We will have Steve Roderick next, who was a middle school teacher and working with the Concord Consortium, middle school science teacher. He will talk about mentoring in middle school for use of system dynamics modeling. And finally, we are lucky to have Greg Orpin, who is the, well, I want to say principal, but it's more than that. It's like the master of IACS, the master person in charge of having IACS, the international, oh, come on, it's not coming. It's the
Innovation
Academy.
Yeah.
Innovation Academy, sorry. Could be international, but it's not. Innovation Academy Charter School, which has done for quite a number of years, grades 5 through 12, focused on systems thinking and system dynamics throughout the school. And one of the main reasons that focus keeps going, and his partner, Rachel Molinar, who is one of the Forrester Fellows, who is a mentor, they will present third. So I'll quit talking so we can have our first presentation start. And thank you very much, Meltem and Emre.
Okay, let me go first and share my screen. Okay. So first, I want to talk about the context in which the mentoring process takes place in Turkey. I'm a member of the Systems Thinking Association in Turkey. I'm a retired industrial engineer with lots of time. It will be clear in a few minutes why this detail is important. Since 2014, we've been trying to run a cycle of infusion. This cycle has three main components. You can see these components on the slide. The first one is implementer workshops. The workshop started in 2014 as a one-week course led by Sherry Marlin of Waters Center for Systems Thinking. Over time, they've evolved and adapted to the changing conditions in Turkey. Currently, the workshop consists of a half-day self-paced online course shown as ESDX in the table, and a half-day interactive, preferably in-person, workshop for the teachers who completed the online course. There are two filters through these workshops. The teacher has to complete the first part to attend the second part, and then complete the second to proceed to the next phase. So as well as giving people the basics of systems thinking, the workshops also act like a semi-permeable filter. The next component that naturally follows is mentoring and implementation. I will give more information on this phase in the next slide, but before that, I want to mention the third component, which is the experience sharing symposium. This event has mainly two purposes. It is a short-term, concrete, achievable, and motivating target for the implementer teachers, and a very effective way of accessing teachers who might be interested. And now for mentoring, what do I understand by mentoring? Before this presentation, I did a little research on meaning of mentoring, coaching, supporting, and consulting. I could not find an exclusive definition of mentoring, so I decided to explain what I am doing and leave it up to you to name it. I organize weekly meetings on site or online with one or two teachers, which usually lasts about an hour. Uh, the agenda is always based on a topic that the teacher chooses from the curriculum. The aim is to increase the effectiveness of the lesson with systems thinking tools. That's why we try to choose a topic that students find difficult. Although there might be some other tools, I prefer to use stock flow diagrams and behavior over time graphs. If needed, causal loop diagrams may be used, but they might quickly become very confusing, especially for beginners. So this is my definition. Choose a difficult topic in the curriculum and work with the teacher one-on-one. So this is what I've been doing for the last 10 years. The graph shows the total number of meetings I have had with the teachers per month. The blue color represents the schools and the yellow is for the education departments of universities. As you can see, academic meetings started 5 years after classroom implementations. In universities, lesson development in schools becomes course developments and support for researchers, again through weekly meetings. The yearly moving averages show 10 meetings per month for academia and 20 meetings per month for schools. That means 30 meetings per month, which is actually more than one meeting per day if we take into account weekends and holidays. This slide is about the process of developing a lesson. The topic is not that important, female product reproduction system. Probably it is not relevant to most of you really interested in biology. But what I want to show here is the iterative nature of the process. 16 revisions were made in 17 weeks. This clearly shows that mentoring, or at least what I'm trying to do, is not just having meetings, but doing hard work between meetings. That's why being retired and having lots of time is important. It takes time, very much time. If that time were charged, it would be too expensive, making it impossible. So the most effective way seems to be free of charge. This is the last slide. I want to end this presentation with words inspired by Isaac Newton's words. If we have dared to try this, it is by standing on the shoulders of giants. We are very grateful to the giants of the field. We greet them with deep respect, and thank you for your patience.
Maybe I can continue, Diane.
Yes, please, Milton.
Yes. Okay. Okay. My screen is okay for everybody. Can you see it?
Now okay.
All right. Hello everyone. It's nice to see all of you here. Thank you for coming. And I just want to share the case study that Emre mentioned a little bit. My school is a Darüşşafaka educational school. It's a boarding school for from 5th grade to the 12th grade, and based on Istanbul, located in Istanbul. It's a boarding school, and almost 5 years ago, we began the first attempts that integrating the system thinking, system dynamics tools into the curricula and into the school environment. And I'm representing my school plus Systems Thinking Association in Turkey, like Emre, and also I'm an instructor at Boğaziçi University. Mainly, I will just focus on the experiences that we have as a mentoring at Darüşşafaka Education Institution. For mentoring, I'd like to emphasize that not for the teachers, but also for our school, mentoring is very important. For teachers, since I'm a school administrator, I'm working almost more than 20 years at that institution, and it's a non-profit organization and support the whole students who are diseased or lost their mothers, and that's why the equal opportunity is very important for the whole school to raise in order to raise the children, and especially not the child but also the teachers are very important for us, because by the help of them we succeed that aim. For teachers, mentoring is, for us as a school administrators, and mentoring is very important for us for gaining the insights and developing essential skills in teachers, with the teachers, and also professional networks that also extend by mentoring systems and also accelerate their career growth in mainly, I can tell. And for our school environment, we would like to foster our culture of learning. That's very important for us. So we would like to always be learning organization, and also we would like to develop a strong pipeline for future mentors also at the same time, because there is a peer process, peer working at the same time, that we would like to see some future mentors at the same time in this process. And mainly what we put the responsibilities under the mentoring system is that provide the guidance in the light of system thinking. And also we would like to offer them a feedback, and that constructive, honest, and timely feedback, because on time, how occurs is important, and it's also important for teachers' growth at the same time. And also we would like to always have a responsibility for school administrator also foster the development of teachers. That would like to see some teachers that they step out their comfort zone and have a new journey to explore new opportunities. That's the main responsibility in our school. In our school, we use this model, the area of teacher competencies, that developed by Reiser and Dick. And by the mentoring system, what we touch actually is that the attitudes that we would like to foster learning mainly, and also the instruction decision making in the planning side, implementing side, and evaluating side. These are the direct touches, but also knowledge of subject matters plus repertoire of teaching skills also is an indirect touch by the help of mentoring systems. What we do actually in planning side, I mentor the teachers, but also at the same time, mainly the association, I and the teachers, and sometimes the other colleagues in the same department, or maybe the head of the department, or sometimes the other departments join us and to think together. That also that foster the interdisciplinary approaches. That's the heart of the system thinking, and an implementation process that the learning materials that we give the feedback, or inside during the lessons, I join the lessons, and this implementation process that I also try to mentor. And in the evaluation that after the lesson, or sometimes during the lesson, because we mostly adapt or implement the materials or the lessons in whole term, in whole classes in the same term. That's why more than 5 or more than sometimes 4 times we implemented in different classes. That's why sometimes after the first or the second lesson we see some changes, or we need some changes. That's why we also come together with Emre and Ülkem, and also, with the teachers, that what happened, and if there's any changes in the model or in the materials, that we quickly take actions with them. And in the process, how we began, there's a big cycle, that the first time that when the teachers come in August for preparation for the new year, we gave a course where we make an introduction to the whole teachers, and we invite them to take the introduction online courses, ESED 101 that Emma mentioned. And after that, we ask them that you would like to continue or not. And in each steps that we are very slow, very welcome on it. And also, if they would like to continue to do it, we give them a workshop that mostly subject-based, small groups and subject-based workshops that we offer them. And after that, we ask them again that, do you want to continue? Do you want to implement? Or do you want to at least develop some materials or lessons? And this continue whole year, actually. That's why we join to the planning, learning, and assessment processes of the courses, or of anything that the teachers develop in that period. And at the end of the whole year, we always make an evaluation meeting for the teachers to see this mentoring system, how it works, what kind of improvements we needed. That's in June, between June and August, we have time to take an action between June and August. In mentoring, what we do, a little bit, Emre explained that as a content, topics from the curriculum, they come, they offer. Sometimes the students have a difficulty to understand, or sometimes the teachers would like to say that, we would like to have a new and more efficient ways to teach it. That's also another need. And sometimes they want to organize their social club curriculum. That's not so concrete. That's why that's open to teachers' creativity, teachers' mentality, teachers' skills is mainly very guiding the curriculum of the social clubs. And for example, we have one experience about it. We designed the whole year's ecology clubs by every month, every week we meet with the teachers, and one in math and one science teacher that opened this course together, opened this social club together, and we designed the whole course by the system thinking approach. And also sometimes the last 2 years we work science project. The teachers offer that they would like to make a science project, and scientific project, not mainly science project, but scientific projects. But they would like to use system thinking or system dynamic tools behind it or with it. In high school, we had one experiences in literature, in Turkish literature, and 3 experiences we had in middle school. In middle school, 2 of them were related with math. One of them was related with health, with science. And that's why they also would like to have mentoring with these scientific projects that works with the students after the school. And mentoring is not just creating or implementing or evaluating the courses or the needs, but also but by this process, the teachers have new opportunities to their professional growth, actually, because they say that we would like to share with other teachers in schools or out of school, national or international, and they would like to join to the workshop, or they want to create a workshop. That's the how what kind of materials they or she or he developed. Or sometimes they would like to apply for the presentation to any conference or symposium with their presentation, what they implemented, what they created. And that's why we also try to help these processes and give the feedback to the presentation, or give the feedback for the workshop content, or any time when they want to have this mentoring, they offer us and they come us and say that we need this to go further. That's why this is not just only one shot, but it's always ongoing, and it's always kind of a cycle, actually, that growth and growth. And as a school administrator, what is the right things, I think, when we are, or I am doing mentoring with Emre and Ülken with the association, is that waiting for the right time is very important for mentoring. For example, when I met with Sistem Thinking in 2018 and 2017, I wait almost 1.5 years for the right time, for the right environment, and that will grow and cultivate with the school and with the right teachers that who would like to improve, himself, herself, and the school environment and learning environment, who are eager to do it. And also teachers' flexibility is important. And what I see in that period, that there is a three type of teachers, or maybe the people in general. One group of people who are the Rogers model is early adopter. Whatever the situation is, they are always going and trying to new things. But some people who are in the middle, especially some teachers in the middle, and they are just listening to the environment, they are just looking to the environment. They might have adapt to the early adapters, or they may stay in the comfort zone. And I need to find out these people to take them to the other level. And that's why right time, right persons, observing the people who are in this middle or not. And very important stuff in schools, that school is very tough, very time limited with limited time. The teachers are creating a lot of urgent stuff they have. That's why in this whole rush environment, you need to find out the safe areas, and you need to put the growth in the middle and give this trust is important. That's why sometimes the plan that you created, or the material that you created together, is not working in this year because of the time limitation. But you don't need, as a mentor, you should always keep in your mind that nothing is important. The main thing is the teacher's trust, and nothing to be rushed. And that's why I always observe the motivation of the teachers and encourage them to do new things and come up with solutions with them, because the environment that you surrounded teachers, you need to think about this as well. For the new things, the school also needs to accept it, that something is happening and something can be good, or sometimes need to time to more developed. And that's why the school environment that you surrounded the teachers is very important. And as a school administrator for mentoring, I need to keep this climate also very safe. And this, I really like the idea of the interdisciplinarity of system thinking that I see in the teachers, that how we develop in mentoring system. They sometimes they just by themselves, they just say that, please, we would like to join to the other subject areas planning, or we would like to see their lessons as well, how they implement it. This is very important with the collaboration they work, and that's why not just us or association mentor them, but also the peer mentoring us is very important, because the mentors, when they have more, when the teachers with more experience with systems thinking, we take the new teachers to their lessons, that they also see how it works, how it's possible, what kind of difficulties they may have, or what kind of points they need to see. This is a big environment in the school that we need to see this bigger picture, rather than just giving one-to-one mentoring or a group of mentoring. I have also take mentoring from the association for my academic course in Boğaziçi University, from the syllabus, from the course material, from the homeworks to the assessment and evaluation. We design my academic course by the help of association. That's my personal mentoring I took from the association also, but it's just for information I put it this. And Emre is a little bit mention about it. But I I wanted to express especially the Darüşşafaka's system for with you. Thank you so much.
Thank you, Meltem.
Yes.
It's very interesting, and we appreciate the information that you shared. Thank you. Let's go straight to Steve. Steve, you're muted, so make sure you unmute.
Okay, first I'll unmute.
We are ready for you.
Okay. Can everybody see that?
Yes.
Great. I'm going to take you on a slightly different journey through this. It's going to be much more personal. It's sort of a case study for some mentoring that I have done over, I guess it was probably 3 years ago that I did this with a teacher in middle school in Michigan. And to start, I thought I'd give you a little bit of background just to give some context about where I'm coming from. So I have spent most of my career as a classroom teacher, primarily in high school, not in middle school. I did teach a couple of years of middle school, but I was primarily a high school biology teacher, head of a science department at a fairly large public high school outside of Boston. And my first exposure to system dynamics was actually a long time ago. It was back in 1971 when I was an undergraduate. And that's an interesting story, but one I think I'll save for another time. In 2016, I retired from teaching, and I started a second career with a person who's here in this meeting with me at the Concord Consortium. Dan Damlin, he had been a chemistry teacher at the high school when I was head of the science department there. And I was lucky enough to get involved with some grant proposals that he was applying for at the time that were trying to bring systems thinking and system dynamics modeling into classrooms. So since 2016, I've been working with the Concord Consortium. And the Concord Consortium is a nonprofit educational research company it's funded primarily through federal grants, mostly from the National Science Foundation. And part of its mission is really to develop and to test new technologies in science classrooms and to create curriculum within which those technologies can be used. And my work at the consortium has been really as a curriculum developer. And there are two tools in particular that I've been using a lot in the work that I've done with mentoring with teachers. One of them is called CODAP. CODAP, you can see it here. It stands for Common Online Data Analysis Platform. And it is a data collection, data analysis tool that's intuitive for younger students. And you'll see a little bit of that as I go through this presentation. The other piece of software is a program called Sage Modeler, which is a I guess we'll call it a semi-quantitative approach to system dynamics that is a little more intuitive and easier to use than a program where you have to create mathematical formulas. So you'll be seeing some of that in the presentation as well. So while teaching, I did a lot of one-on-one mentoring because I was using system dynamics in my classes. And I was trying to get colleagues to use systems thinking and SD in their own classrooms. But, you know, I had my own classes to think about. And there were times when that mentoring really felt kind of haphazard and disjointed. And in my role at Concord, I have a much different take on this because I'm actually hired to be kind of a consultant to the teachers. We're trying to bring these tools into the classrooms, and we're trying to get them to use them in ways that enhance systems thinking and system modeling in the classes. So I've been blessed with the ability to kind of walk into a teacher's office to talk to that teacher about what their hopes and aspirations are for a unit, to sit down with them, co-plan the unit together, and then actually be in the classroom for some of the time that they're working with the teachers. And the kind of case study that I'm going to lead you through here is an example of how that happened with this teacher in Michigan. So before beginning, I sat down and I sketched out a plan for how I thought we might think about using systems and modeling in any science classroom. And I hope that we could get the students to become comfortable with 4 different but related aspects of modeling. And you can see them here. One of them is interconnection and causality. We've got data generated over time. And for that, we're going to be using, or I was using an approach called project-based learning, or PBL. Stocks and flows are certainly important, and accumulation, the idea of accumulation, and also feedback. I wanted to get all of these things into the curriculum and to use modeling itself as the centerpiece for all of that. So I took all of this to this middle school teacher, and in our first meeting, we discussed applying the use of systems ideas and modeling to a specific unit that the students were studying. And that unit was global climate change. And the teacher's initial learning goals were, as you see here, they were different. She wanted the students to know that there were different forms of energy, wanted to know the difference between heat and temperature, that energy was transmitted and could be transferred through a system. She wanted them to know a little bit about the greenhouse effect and some of the implications to planet Earth. And she had an activity that she had typically used and had felt was fairly successful in the past, where she would kind of introduce the topic through video, through readings, through class discussions. She used a diagram here that you probably have seen before, or at least something like this, showing how energy flows through the global system. And one of her students' parent had a Mini Cooper. And so she said, well, you know, maybe I can use a Mini Cooper as an example, an analogy to what's going on in the global climate. So she created this activity where she wanted students to take all of the background information that they had and to apply it to this Mini Cooper in an analogous way to what's going on in the global system. So here's an example of some student work that they got. They created a drawing, essentially a model of this. And what the teacher was hoping was that there would be some kind of connection within the student's brain between what they had drawn here and the model that they had been given to begin with and that had been discussed. Well, this teacher it was interesting to talk to the teacher about this, because although she thought that this was a fairly successful activity, it also had proved to be extremely abstract for a lot of the kids, and they had a lot of difficulty kind of internalizing the connection between this model they had drawn and what was going on in the global system. So we started talking about, how could we take that particular activity and make it into something that was a little more engaging to the student themselves. So it was at this point that I showed her this diagram that I had come up with before I had talked to her in the first place. And so what we did was we decided to take the 4 aspects of that diagram and to then bring them to this activity. So the first aspect was interconnection and causality. And the question that she was really asking the students to grapple with was, why does the inside of the car get so hot on a sunny day? So how could we make this more engaging? So what we did was we decided to bring in Sage Modeler here. We gave the students a little introduction to how to use Sage Modeler in order to create a causal diagram. This is not a dynamic diagram at all. This is just a causal diagram, much like a concept map, if you were to look at it. And she presented this to the class, the question of, what's going on inside of the car. And the students put together their ideas of what they thought was going on inside of the car based on what they knew. So we have here, a few examples of that. There were some students thought very linearly. Like here's one where the sun comes in, the energy goes into the seats of the car, goes into the air in the car, goes out through the atmosphere and then out into space. There was another student who started looking at other pieces of the system that might be impacting the flow of energy. They included clouds. They actually connected the energy that was in the car to the temperature, because there had been some conversation about temperature being the average kinetic energy of molecules moving. So this was a really interesting way to get to probe a little bit into what the students already understood, as well as to start to give them a sense of the complexity of a system with multiple components and with connections among those components. Okay. And although these models were interesting and they got plenty of insight into what the students were understanding, they were static, right? And it was important to the teacher that the students see how climate problems are actually dynamic, and that by being dynamic, that means that they're able to be changed. So we could actually make things better over time if we knew about that. So we had to bring this idea of behavior over time into the activity as well. So to do that, we went and we looked into some of the work that's been done around project-based learning. And we brought into the activity the use of CODAP, which is this tool that enables students to both gather data and to analyze it as well. And what the teacher did was to offer the students some materials that could be used in an experiment that might be analogous to what was going on inside of the car. Put them all out and said, okay, look, I want you to take these things and come up with some kind of experiment that you might be able to perform that would collect data over time. So some of the tools that were available to them were these portable wireless sensors. One of them was a temperature sensor from Vernier. And a number of these groups put together experiments where they took a mason jar, they put some colored cloth inside of the mason jar along with the temperature probe, either closed the jar or left it open, and then attached this wireless probe to the computer so that they could collect the data over time. And this project enabled them to generate behavior over time graphs. Now, before they actually performed the experiment, they were asked to predict what they thought the results were. And most of the kids in the class predicted something like this. They predicted a very linear growth of the temperature inside of the jar. But what they actually got after doing the experiment was something that looked like this. So the teacher, this was interesting. The teacher posted both of these, or displayed both of these in front of the class and said, let's talk about them. And there were some really interesting discussions that came up around, what was going on in this graph? Why was it going up so fast at first? And then it seems to be leveling off. What was going on here? Turns out that this is where they actually took the jar out of the sunlight, brought it back into the classroom. So some very interesting conversations that went on here. So this idea that things can change over time, they're not static, began to sort of foment inside of the students. But we wanted to bring it back to the modeling again. So, what is it about the models that enables this change over time? So that brought us into this idea of stocks and flows and accumulations. And the teacher brought back models that had been created at the outset, these more static models by the students, and displayed them again and asked the students to look at them and decide what within each of these models that they were seeing could be accumulations of something. So they would go through and they would indicate what the accumulators were. So in this model, this is a fairly simple one here, but they thought that the energy inside of the car, where the car is heating up, is something that accumulated. The temperature they thought was something that accumulated. The outside air temperature could be accumulating if it was going up. This is not as simple as it seems. I mean, there are a lot of kids I remember from being in the class that thought that, the clouds would be accumulating as well, right? Potentially. But it was a great time, an opportunity for the teacher to begin talking and discussing with the students about the fact that the time frame of the model is really important as well. And that within the time frame that we're considering for this jar, the clouds are not really an issue, right? And so that's not something that we would consider as an accumulation. So they first of all went through the static models and indicated what would be accumulating. And then the teacher went back and gave them a little more instruction on the use of Sage Modeler, which also has a dynamic mode to it. And the students took the static models and, with the help of the teacher and with me in the classroom, kind of moved it over to being a more dynamic look at this. So this is a look at what Sage Modeler looks like in dynamic mode, where we have the heat accumulating in the car as the stock. We have a flow here that flows energy into the car, and we have an outflow going out to the outside of the car. And the heat that's accumulating in the car is an indicator of what the temperature is going to be. So the students worked with this a little bit and they simulated, and lo and behold, they actually got data that looked a lot like their prediction. So the heat was accumulating in the car in a linear fashion, and the temperature was accumulating in the car in a linear fashion. But hey, that isn't what the data showed. So what do we do about that? So to work with that, we had to come back to this final aspect of the systems network that we had proposed at the beginning of all of this, and start talking about feedback. So the teacher would display again what the simulation showed, which was this linear growth, what the experimental results showed, which was a growth, but topping out at some limit at the top. And bringing back the model, there was discussion about, well, what could be wrong with the model? What could we do to the model potentially that would actually change the behavior? And one of the students, luckily with a little bit of help and prompting from the teacher, realized that there was a kind of feedback that was happening here, that if you had more heat accumulated in the car itself, that you're probably going to have more energy flowing out, right? If the car is cool, you're not going to have as much energy flowing out of the car. If the car is hot, you're going to have more flowing out. So they created this feedback loop, which turns out to be a balancing feedback loop in Sage Modeler, put it into the model, Here you can see it. And then simulated and found out that the temperature actually went up and topped off. So using CODAP, the students were enabled to take the data that they had from the actual experiment and compare it to the data from the simulation and get a sense that, in fact, the feedback is really, really important here. So what's this all about? Well, all the models are wrong, right? We know this, George Box said this, but all models can be useful, right? And so by useful here, what I'm calling useful is that the students have now become more in tune with the fact that feedback is an important part of systems, right? That feedback relationships can play a very, very important role in the behavior of any system. So it's here that my mentoring ended with the teacher, right? We managed to bring all 4 of the fundamental aspects of systems into the student experience, and we used model creation as the centerpiece. But the question I always have is, well, what happens afterwards, you know? So there's been some mentoring that's gone on. The teacher knows a little bit more. The teachers have, or the students have gained some experience. But what's next? So for the students, I think it's this, the opportunity to bring these ideas along with these new tools, these new skills, these new perspectives into the work they do in all their classes. That's one thing that I think is the next step. And then the other one, I think, is that they can now apply what they've learned in this small set of activities to the global issues that are surrounding climate change. So within the class, it can expand out. And this model that you see here is essentially the same model that a student took and just changed all of the labels for the different components to match what's going on in the global system. For the teacher, I think using what they have learned and experienced to foster engagement, new understandings for all the students and in all their units across the curriculum, they certainly have gained new ways of understanding their subject area. And I didn't have time to find this, but this teacher actually started using actual model diagrams, dynamic model diagrams, as assessment tools. So on the final exam, they would like present a model and have the teacher or have the student describe what was actually going on in the model and use that as an assessment tool. So finally, what have I learned from all of this? Well, a few things. Mentoring about systems often involves helping teachers think differently about what they teach. Mentoring remotely is not as successful as being with the teacher during planning and execution. I've also tried to do this online during the COVID period. It worked, but not quite as well. Mentoring about dynamic systems takes time. Let's see, we have this quote from Barry. Though dynamic thinking is one of the easiest of the systems thinking skills to master, it does not come naturally to most people. And finally, teachers value and appreciate the chance to work cooperatively toward an important goal. And it wasn't this teacher, but another teacher that I worked with made this statement that my students have made amazing progress, and working with you has had a huge impact on me gaining confidence with systems. So that personal connection, I think, is so very, very important. So there it is. That's my presentation. And we'll move on to Greg. If you're more interested in Concord and what we do there, this is how you can find out about it.
Thank you, Steve, very much. Greg, let's go directly to you.
Great. Thank you all. It's nice to see some familiar faces and as well as some new ones. So I'm happy to share some of the work that we've done here at Innovation Academy. I'm grateful that Rachel is joining me. So just a quick, if you've never heard of our school before, I'm guessing most of you haven't, we're located in the state of Massachusetts. We are a school that was founded in 1996. We serve grades 5 through 12, about 100 students per grade. And one of the things that makes us unique as a as a charter school, which is sort of a specific type of public school in Massachusetts or in the United States, is they're often guided by school-specific missions. And one of the things that makes our school unique from others is a longstanding commitment to integrating systems thinking into the curriculum and the broader work of the school. And so that paragraph quote there is actually original language that was written into our school's charter almost 30 years ago, before we were open, and we still continue to do this work today. So when we think about the overarching goal of trying to build systems thinking capacity, teacher mentoring is clearly an important part of it, but there are other elements that are really important to creating an organization that moves systems thinking work forward. And so want to just touch on a few of those so you can see sort of the work of building capacity is done at multiple levels of our school, right? It starts off with our board of trustees that is really charged with thinking about the long-term health and viability of the school, as well as administrators like myself who are tasked with the sort of day-to-day oversight of the school work, and as well as the teachers who are obviously on the front lines working with students in the classroom. But we also see teacher mentoring is not just about building capacity, but helping reduce the extent to which accumulated knowledge does not leave the system, right? So I think that's an important thing that makes sort of teacher mentoring a particularly high leverage part of our school's work. So as I've been in my position as the head of school, dating back to 2013, and as long as I've been on the board, there have been strong leaders in the field of systems thinking in K-12 education. So my close friend and colleague, Alan Tchaikovsky, who's authored several really wonderful books. We'll share the slides out so that there's links to where you can get these books if you haven't used them or read them or tried them out with your students in the classroom. I'd highly recommend them. They certainly they've been helpful resources for our work here at Innovation. And then hopefully folks are familiar with the Creative Learning Exchange. Lee Stuntz is the executive director of the Creative Learning Exchange. She's been a valuable member of our board for the past 10 years. Alan, again, who's on the call, has been on our board since 2019, and excited that Alan's longtime colleague and a colleague of mine and a colleague of Rachel's, Rob Quadden, who is also retired, will be joining our board. And I point out the importance of having board expertise because systems is just one of many sort of educational reform efforts, and I think sometimes they come and go, and I have found it to be particularly important to make sure that at the highest levels of the school there's a commitment to the work. In terms of administrative work, one of the programs that we've had running for the past about 6 years is a program at our school called the Forrester Fellowship, obviously named after Jay Forrester. You can see our fellowship team consists of myself and Rachel and 3 of our colleagues. As you'll notice by the disciplines they represent, we're an interdisciplinary group of educators. And I did note in Meltem's presentation sort of the importance of systems improving interdisciplinary thinking and the importance of collaboration. And I think this group, as a school administrator that is tasked with a lot of things that are sort of unrelated to teaching and learning, it's been a gift for me to sort of engage with this group. And I think it's a really good example of what Peter Senge described, articulated as team learning. So A little bit about the work of this group of five. So we will do many things together. Sometimes we're explicitly just sharing personal work that we are executing in our schools. That could be a English lesson plan that Stephanie wants to bring. It could be a math lesson plan Rachel wants to bring to her classroom. It could be an administrative topic. And we just sort of have a core group that has time to collaborate to review our work together. Sometimes we just practice doing systems work. And so taking a current events article from a newspaper or magazine and just taking an hour in our monthly meeting to deconstruct it and sort of apply systems tools and to sort of, sharpen our own skills. The other important element of that this group does is, and it's core to our work as a charter schools, to help disseminate and share information out to broader audiences. So this group, attending and presenting at workshops like today would be an example, but this group has done some active writing through the Creative Learning Exchange, has led workshops at local conferences for K through 12 teachers. So again, part of the output is to not only write for publication, but also to help lead and share this work with external audiences. But then we also do a lot of important work internally, right? So this group really helps lead the work here at Innovation and to help further the systems work by working with our own colleagues. That's just a sort of a background of just like an administrative structure that has helped continue the work here. And Rachel is going to speak a little bit about, as a Forrester Fellow, how she has then taken her experiences as a fellow, what that looks like working with her high school math department.
Okay, so thanks, Greg, for passing that on to me. I put my pictures of the high school math team up in part to just be like, yay, people who are working hard at math, but also to highlight the relative newness to teaching and to our school. So these are teachers who have been here for the most part either 1 year or 2 years, and that sort of informs a lot of my approach on asking them to add to the work of getting used to our school and getting used to teaching and meeting our students. Like, oh, also, we're going to ask you to incorporate systems thinking and system dynamics into your curriculum. So at our school with new teachers, we know that this is often something they haven't encountered before. And we do have a program in place to introduce them to the basic concepts of systems thinking and system dynamics. And we don't require new teachers to do this right away. But what I want to say is that I've found that if we provide a lot of support and a lot of one-on-one mentoring, but also course materials that we know will work, the new teachers are usually willing to give it a try, regardless of their own personal familiarity with the content. So I found that when we do departmental professional development around systems thinking, what gets the best response from teachers and the most willingness to try is when there's like most of the curriculum pieces are in place for them so that the lift for them to incorporate this into their classroom is less. And then also they feel a lot of personal success when they try the course materials themselves. So some of the things that I've developed is a credit card debt lesson. I developed a higher level lesson for my Calc 2 students that we have imaginary animals called bumbles and woofs that are in a predator-prey relationship. But we've also used some of the resources from the Creative Learning Exchange. So in particular, the Model Mysteries book, and then also the simulations that they have online. And then this year, my colleague Tim and I went to the Association of Math Teachers in Massachusetts and gave a presentation using how to use model mysteries, in particular the zombie chickens lesson, about how to relate that to learning about exponential curves in the math classroom. The other thing that's key, especially, Bye, Daniel. Thanks for coming. Is to make sure that the systems thinking lessons are incorporated into the curriculum that we also need to teach our students, because there's other considerations, of course, too. So Greg, if you want to just go to the next slide, I'll wrap it up quickly. I just wanted to give you an example of the lesson that's been the most successful at our school in terms of getting new teachers feeling comfortable and confident to teach a modeling lesson in their classes. And the key is to have it start very open-ended and just sort of explain the situation to the students. So in this case, it's this is like about halfway through the lesson, we ask them to think about, now that you've built a couple models and you understand a little bit about repaying debt, what would you need to change in the model in order to reflect interest rates being quite high on credit cards? And then after a very open-ended page, I say, okay, now I'm going to provide you with a working model. So the students are stepped through how to build a working model so that they don't have to struggle too much with this new step. And this also helps new teachers because then they feel confident helping the students build something that's definitely going to work. And then at the end, we ask some specific questions on how to use the model to calculate things, but then also more open-ended questions about like, what could you change? Where do you see there a problem developing? Why is it like this? So that's how we've been doing it the last couple of years in the math department. I'll pass it back to Diana, I think.
Thank you very much. Well, these were very stimulating conversations, presentations, and somewhat different mentoring approaches, which I think is always useful to see. So I would like to, first of all, I'm so sorry, Steve, about saying that you were a middle school teacher. It seems like always we ask you to represent middle school teachers, and I apologize for that mistake. And of course, to Greg, for I always know what IX stands for, except when I'm in front of an audience and I can't get the right words out. I apologize for that. Please, I'd like to open up the conversation for anyone who would like to ask our presenters questions. Of course, if you don't ask, I will always say something. Ed, go ahead.
This has been really impressive. I've been out of touch for a while, and I'm realizing that I don't want to be out of touch. This is my tribe. You guys are talking about all the right stuff. I wanted to make a comment to, I think maybe Rachel. I was thinking about this through all of the presentations, but it may be most relevant, directly relevant to Rachel's introduction to the new teachers, that whole process. My background is medical research as an associate professor running a research lab, so not a clinician, but working with medical students and graduate students. And one of the concepts, probably worldwide, but definitely in US medical education, is the idea of watch one, do one, teach one. And that is, so new medical student comes in, they're doing a rotation, and this kind of carries through all of how medicine works, from being a student to becoming an intern to becoming a resident. And that is, you watch a procedure, they say watch one, you might watch several, it might not go quite lockstep like that, but the idea is that you're going to progress through watching this and getting acquainted with it, actually doing it and getting more acquainted with it, and then actually teaching it. That's part of the deal. And as I'm sure we've all learned, when you take geometry, you look at a progression, in math progression, you take geometry, you learn all this, nitpicky stuff. You actually learn geometry when you take trigonometry. Then the geometry starts making sense. You start learning trigonometry when you take calculus. It's not until you actually start using it. And in medicine, you take a histology course is how tissues look and structures and so on. And that starts making sense when you take a pathology course and you use the histology and you look back at all the things that aren't quite working. So the point is here that especially for the new teachers that Rachel was talking about, I was thinking if the first one, an introductory lesson, what are sock and flow diagrams, just the concept of that. So they're getting exposed to that. And then they either would preferably build a very simple model, just a bathtub model, something like that, and play around with it a little bit so that they're actually doing one. But very shortly after that, and I'm not talking about going into the classroom and teaching it, I'm talking about teaching their peers. They would also be going into the classroom, obviously, but their learning process is going to involve what did I just learn and what do I need to be able to teach the person, myself, from a month ago, or and if they know that they're going to be doing that, they're going to be thinking that way from day one, from the time that they're seeing one to then they're going to do one, and they know that they're now going to be teaching this. So it changes your mindset where you're thinking of what are the pieces of this that I need to present to, the next people down the line. So I'll leave it at that. But that applies to all of the mentoring that you're all doing. The organization has to be set up right to do that. And some of the ones the other presentations, that's not quite the focus of what you're doing. When you're working with teachers on a particular curriculum piece, they're not in a position to teach other teachers that. So it kind of depends on the scope of what you're doing and kind of the stage of where you're at. So Rachel, you're muted. You're muted, Rachel. I see your mouth moving.
Okay.
There you go. I just want to say I really do appreciate that analogy, and it rings very true for my personal experience and also my experience teaching teachers and teaching students, is that the really true learning comes when you have to explain what you think you understand to someone who's learning about it.
Yeah.
Thank you very much.
Diane, can I ask
What?
Greg and Rachel a question? Is there
Sure.
Is there efforts to reach out to colleges that train teachers to include system thinking in their curriculum?
We have had discussions around it. I think it is. I don't know of many examples where sort of it has of pre-service programs, at least ones that are geographically near us that are looking to do it. However, there are some that has sort of been a more recent conversation in our Forrester Fellows group in terms of in addition to sort of going to traditional conferences and workshops, like can we reach out to local teacher education programs to see if they might be interested in, say, like a science methods course, having one of us come over and introduce some modeling and expose them to that. So I wish there were more examples, and there certainly may be ones that I'm just not aware of, but I certainly think that's an area for growth for sure.
Diane, excuse me, one last thing. Do you reach out to the public schools? Is there any interaction? And I'm going to be quiet, Diane, I promise. Is there any interactions with the public schools?
Yeah, so I think the best place to get those connected are at some of the conferences. Like Rachel mentioned, the mathematics conference that she went out to earlier this spring. Jason, one of our social studies teachers, is actually presented last year and has already just found out he got it conference presentation for a national conference that's for social studies teachers in Boston next November. So I think that tends to be like the best forum to connect with other teachers at shared professional workshops. And in the past year and a half, it's really exciting that of the 3 proposals that Jason and Rachel have submitted, all 3 were accepted. So hopefully that's a sign that there's some good appetite out there.
I would like to say one thing before. I want to call on Kim because she's been waiting a long time. Actually, we have 4 people with their hands up. There has been significant work going to training and getting infusion in teacher training programs, K-12 teacher training programs in Turkey, and they can tell you a lot. And I don't want to have that conversation right this minute, but I want to make sure we have it before we quit, because they have some things they can tell you that are very important. What I really want to do now is call on Kim.
Just to comment on your last point, having collaborated in teaching a science methods course at Teachers College in Columbia, I think it's going to be very hard to get that into teacher training in the United States because there's not very much time, and it's a complicated topic, which is closely related to the question that I originally wanted to ask, which is all 3 talks show versions of mentoring that are extremely labor intensive, especially the first talk, 30 hours per week of sort of individualized attention from a mentor to a mentee. This is not scalable. And I wondered if any of you would like to comment on, number one, why is this requiring so much intensive mentoring? What is it that's so hard? And secondly, do you have any ideas about how to scale this up to be more time efficient?
Emery?
Well, maybe 2 things can be said about this, or at least I think of 2. The first one is, I hope this is an reinforcing loop, and that labor part is from getting 0 to 1. And after that, the doubling time, it will take much less. And actually, we in Turkey have just seen that, I think, a couple of weeks ago, the Ministry of Education included systems thinking in the curriculum, in the framework of the curriculum, not as an outcome, but one step before the outcome. And some of the academicians that make this possible is within this group. Now they are watching. But for this to happen, that amount of that amount of effort, I think should be spent. I don't think it is scalable, but that part is not. I am not expecting myself from serving 1.5 million teachers in Turkey. It is impossible for me, but that takes me to the second one, which is the AI part of it. And now we are working on it. And there will be a webinar on September about the results we get. But as far as as far as I can say, that it seems very, very, very possible to clone myself with AI. And if we can do that, there won't be any scaling problem. So this is a serious opportunity. So these two, I think these are my answers.
I hope you will actually come to our September webinar when we talk about using artificial intelligence to support lessons using systems thinking. John, would you like to go next?
Did you mean Joe? I think Diana meant Joe.
Okay. Joe, I meant Joe, and I muted myself before I corrected myself. Okay. Yes, Joe, I apologize.
I have a question for Stephen and maybe Alan. Stephen, you spoke about an engaging topic. Do you think an engaging topic means that students are stakeholder in the model themselves, such as decarbonization of student transportation or composting for cafeteria? Is that an example of an engaging topic and data could be collected, right? The school is a laboratory itself. How important are things like that? And I'll use it to advertise my Tuesday presentation on student transportation and decarbonization on Tuesday. So I'm curious about the actual topics that would engage students and teachers and using the school as a laboratory.
Yeah, so it's a very interesting question and a good one, I think, because engaging for one person is not engaging for another necessarily. And in my experience, I have found that engagement falls in a spectrum. That I believe that what you stated at the outset, that a topic that is personally engaging, where the student finds themselves directly embedded in the problem, is by far the most engaging type of experience. But you can, I've taught school for a lot of years, and you can get kids who just want to get an A, and they think that an engaging topic is whatever the teacher wants them to study, and so they'll get engaged for that reason. But I do believe if you're trying to bring in the masses, that the thing that you want to do is try to create some kind of a boundary around a topic that enables students to get individually engaged in some aspect of what's inside that boundary. And those have been the most successful for sure. And project-based learning, this PBL, if you read up on that, I mean, the question of what makes an engaging topic is a huge one. It's a huge one. So.
Maybe, if it's okay, Diane, I would just give another example of that that idea. This year I worked with some seniors in a math class who, they were a group of students for whom like math did not necessarily come easily and might not be identified as their favorite course. And we did some of this credit card modeling. And so in the United States, until you're 18, you technically can't have a credit card. But many of the students had debit cards that they can carry. So like there's a certain amount of money, and as long as there's money in there, you can spend. So their awareness of interest rates and sort of the impact of interest rates on how much money they would owe if they spent a certain amount of money on a credit card and did not pay it off in the very same month. They were sort of good and outraged on like how much money it was going to cost them. So, I think you could probably say sort of engagement and sort of tapping into students' passions or daily experiences is sort of central to any sort of curricular development. But I especially think when you can touch on topics that sort of get students good and angry about like how the world operates in ways that they are not yet aware, I think that's a nice way to do it.
Are we, anyone else want to say anything before we go to the next person who has a question? Okay, Ilir?
Hello, nice to meet you. It was very nice meeting. I would like to ask especially Turkish group with their experiences comparing to other methods. What would be the pro and contra actually methodologic from the methodologic point of view system dynamics or systems thinking positive ways for teaching. Comparing to other methods, how could you evaluate system dynamics as a methodology for teaching? What would be good and bad experiences from your point for the students? Did I explain well?
I only know a little bit about systems thinking and system dynamics, and I don't know any other teaching method, so I'm completely unqualified to answer this question. Maybe Meltem make a comparison.
Well, from your experiences,
well, within system dynamics, I always prefer stacks and flows. Starting from stacks and flows conceptually.
But what are the reaction of the students? How you would? I'm asking them on the general level, not on the specific level. That some students can quickly probably absorb, but I'm more interested on general level because I'm interested how much system dynamics can have impact in general.
If you start stacks and flows, that very specific tool, it is very concrete. You will have, I'm sure by now, that you will have no problem because there is nearly no conceptualization in a stack and flow. And this is a bus, and when you walk in, when 10 people get into the bus, when they're getting in, so 10 people is a flow, the people in the bus in a stock. You can make countless examples on this. But when you come to a very difficult level of causal loops, because causality is in itself a problem, it's a very hard thing to do, and you are before giving that causality, you are giving two causalities to make the loop. So it is not, at least what I think, not a very good idea to start causal loops. Stock flow diagrams, if started from there, it is very intuitive, very easily connected to a behavior over time graph, because when the behavior is a line going down, that is for that level an outflow, and when it goes up, it's an inflow. And of course, the stock is the variable in the graph. So when you can intuitively start here, and not any teacher can start from here because it is within her reach. But when you get into causal loops, more than one stacks affecting one the other, it might quite rapidly gets very complicated and creates a resistance.
Thank you.
So I have to add my 2 cents worth. I'm sorry, Kim, you're going to have to wait a few minutes. I got to add my 2 cents worth here. So I've been a math teacher for over 35 years, and I used system dynamics in teaching mathematics for 20 years. And I found my students very receptive, especially two groups of students that we do not serve well: students who are not very good with equations. They liked the visual nature of the stock flow diagram with the full words and the plumbing appearance, two-dimensional. They liked that a lot. It helped them understand the problem better. And the students at the top, because you could study problems that you can't normally study in mathematics, because the stock flow diagram opens up more sophisticated problems to students in mathematics. And so the students at the top, who usually are a little bit bored in class, they became very much more included. And I found it extremely stimulating. And of course, it was stimulating for me as well. So I did not find my students, and parents told me that their students liked it and that they wished they had learned it in high school. So it was a very positive experience. I also taught a modeling course, a system dynamics modeling course for a full year, for 20 years at the high school level. And that went extremely well. And with students be able at the end to create their own models of a topic they were interested in. So I think that we can get students interested. That's not the problem, because there are so many problems that this tool allows them to access that they cannot access with traditional mathematics before the use of calculus. And how many kids go to calculus? So few kids go to calculus. And we need them to understand dynamics, and we need them to understand change over time and patterns. Now, Kim has convinced me that I need to add more data in my models, data analysis in my models. So I like trying to take real world data, put it in its own little converter, and have the model try to simulate or match part of the pattern of the data. So there is some checking that their model behavior actually does replicate real world behavior. And so I think that's something we could easily add. I don't think there's any question. The problem is teachers are afraid. They're afraid in mathematics. Now, I can't say for all. I think science teachers are much more flexible, but mathematics teachers are a little bit afraid of modeling. They like the procedures. They don't like the openness that modeling provides. It makes them a little nervous not to know the answer in advance. It makes them a little nervous not to know where the model can go. So sometimes in mathematics, for beginning teachers, guided lessons are much more helpful. It makes them more comfortable. The problem is not the kids. The problem is building confidence in the teachers. Most of the teachers we deal with are already in the classroom. So they've already had their training. They have to be willing to retrain. And not all teachers are willing to do that. And so if you find a teacher who is willing to think a little differently, a little out of the box, take a little bit of a risk, you will have a teacher who is probably primed for learning system dynamics. And the rewards are amazing. It changed me as a teacher. And for the better, it made me a better teacher and much more responsive to my students, because it was kind of like they were teaching me some things and they like that. They like giving you suggestions, and it's really a wonderful experience. So I have to say, the problem is not the students. The problem is convincing the teachers to do it and helping them develop the skill to be confident enough to do it.
Can I add something to that, Diane?
Yes.
So I would say that I think of the other pressure that's coming to bear on a lot of teachers, and I ran into this at the Math Teachers Conference, is that they feel a lot of pressure to cover the curriculum, like a lot of pressure to get through all of these topics. And if they don't see an immediate use for a new thing, They just don't have time for it in their in their year, in their mind, in their learning process. So that's the other like wedge point is like if I can show that this is going to help you teach exponentials,
Right. And
then
I
they're
think
more
that's
interested.
really important.
Yeah.
If we can stay close to the curriculum, we're not telling them they have to add something new to their curriculum. We're helping them do something that they already do better. And I think that's where we're going to hook teachers, is helping them do something that they already do better. And here's where administrators can play a key part, is to give teachers the flexibility to experiment. If they expect teachers to be on a certain page of the book every day of the year, you'll not feel the ability to do any experimenting, which is really too bad, because that's the most fun part of our job, is to experiment with how to do things better. But if administrators are willing to give you that flexibility and support you there, because you're not going to be very good at the beginning, but that you will get better as you practice, that's where they play a huge part in kind of giving teachers permission to experiment. I've got to quit talking. I've got to get to Kim. Okay, Kim, your turn.
So my next question, this is for the first group that spoke and the third group that spoke. You're both in schools that infuse systems thinking basically through middle school and high school, as nearly as I can tell. So, which is awesome in the sense that it gives you the capacity to build year after year after year on what they've learned the previous years. So I would like to know what happens to the students who come from that school when they get to college. They'll hit college and their science teachers, let alone their math teachers, let alone their political science teachers, their economic teachers, their history teachers will never, will not have the slightest concept of teaching with systems dynamics. And I feel like these kids are going to just bang into a brick wall where they, they can't talk to their teachers. They don't like the way their teachers are trying to teach them. They'll find the whole college experience extremely frustrating. And I wonder, do they flame out? Do they rebel? What happens when they get to college?
So, I mean, I could take the first stab at that. Like, I guess the first thing I would say is, one, I've received some sort of fun, upbeat alumni emails like, hey, like I took this course and they're actually using Vensim and not a lot, but like I have seen that happen. And usually it's like a pleasant surprise for the alumni. Um, I think I think the way just knowing sort of my sphere of influence is like, the greater purpose for that work here is just to develop sort of better analytical thinking, better problem solving skills, and just to sort of help them become better and more critical thinkers. And it is probably true that very few of our students are going to be actively building stock and flow models and when they go off to college, but I do think they're sort of the impact of sort of digging deeper and doing some deeper thinking and learning in high school, like, that is sort of like a long-term impact that I think will stick with students.
Melton?
Yes. Actually, it's a kind of a seed, I suppose, because for myself as well, Turkey is a very dynamic country. That's why we just, from my point of view, just for teachers, as a teacher or as a student, we would like to see them that came across with this approach, with system thinking, with system dynamics tools, because if they came across, there is a chance that they can take it in a further time. But if they don't have any chance to meet it, uh, that's the biggest problem. That's why when we give that as much as possibly, we would like to take them periodically. They try to take the frequency that they came across with, but we can't manage or organize properly the future. But the idea, at least if this manage to give the idea properly, it's infused, I suppose, too. That's why it's a kind of a not a big answer that I gave, but just at least came across, I suppose, too.
Greg, I
think
didn't mean to imply that they would be criticizing their high school experience. Conversely, I was envisioning that they would be criticizing their college experience.
And that may be the case, and that should happen. You know, if the kids have better ways of thinking about problems, they ought to kind of respectfully push their teachers to do better. Emre, you want to say something?
I was muted. Actually, we are not trying to create modelers. We are trying to support the higher level thinking skills, and anything we do is better than nothing. So I am not expecting whole society. If it is, it might be much better. But if not, this shouldn't be a thing to stop ourselves or frustrate ourselves. Whatever we do, and actually, I work with kindergarten teachers to high school teachers and some universities. Even there are many schools, only kindergarten or early childhood teachers uses systems thinking tools, and not the primary. We couldn't persuade that part, and we do not think that this is a wasted time. Even that part, it is better than nothing. And with this accumulation, we hope we are in time will come to a limit or a point of much faster increase. But the focus should be support the higher order thinking skills, not to make a ransom or Stella modeler.
Okay, I think we need to go to Ed. He's been waiting a long time.
Yeah, and my comments have changed from what I was going to say based on what I've been hearing from Diana and others in the last few minutes here, and that is the idea of teaching this or getting engaging math teachers who might be uncomfortable with this approach. I think something that when we talk about this all the time, we know this is so ingrained in us that I think we can kind of forget about it, and that is that we think of system dynamics as a technique, and which obviously it is, but really embedded in the technique is the whole concept of problem solving and critical thinking. And so we're faced with, as we saw with the Mini Cooper and a couple other examples that we saw here, is what are the boundaries of the problem? What are the pieces that go into even thinking about it? I mean, the global warming is huge, and we're trying to get that down so it's more relatable, so we make a smaller model with boundaries. That is not what's going on in math courses. They're not teaching critical thinking in math courses. The critical thinking that you're involved in on a day-to-day, week-to-week, is how do I solve the odd-numbered problems at the end of the chapter, which were designed to cover the chapter that you just read.
Well, things are a little different now, but yes, essentially.
Well, yeah. But they're still trying to get, they have a curriculum that they're trying to get through. They're not teaching the students problem solving. They're not asking them to conceptualize the global problem. The goal is to learn the techniques that you ultimately are going to need to solve the problem. So the goal of the math teacher is to get through the curriculum so they can go on to the next math course. And what's the benefit to the math teacher to learning system dynamics? I mean, it seems like it seems almost counterproductive for the math teacher in the classroom.
It depends on what you call mathematics.
Well, I'm talking about the algebra course, the geometry course.
I understand. I have to tell you first, Ed and I are 30 years friends. So I'm interrupting him, and he interrupts me, and it's a very friendly conversation. But and he used to come into my math classes when I was doing system dynamics. So we have a long history. I think things have changed even since I've retired from teaching mathematics. So it's gotten better, but system dynamics has so much to offer. And I think the use of simulations in mathematics is a place that is truly missing in mathematics. The ability to create simulations and use simulations. It's used in the real world all over the place, and we should have it in our classes. So we are missing a real opportunity to provide mathematical background for students. I think you're right, Ed. And, you know, you and I agree on so much. And when I was teaching, it was a lot like what you were saying. But I think there has been significant improvement. But I think there can be much more improvement. And I think system dynamics has a lot that it can provide.
But if a teacher is reluctant, you made a comment that teachers they think they need to know the answers.
Yeah, we tend to like to know the answers.
If that's true, then system dynamics will not work.
It's true. We've got to change. Math teachers, I find, are the hardest to change. We are a little bit too narrow in our vision. Science teachers, on the other hand, from the beginning, they know they can't know everything. So from the beginning, they're much more open to simulations, to different ways to gather information. So they are actually the prime teachers to try to influence first. But I think math teachers are the perfect place to bring this tool in because it's such a valuable tool for understanding the world mathematically through mathematical quantitative eyes.
Unless the math teachers became math teachers because they like doing things methodically.
Well, yeah, self-selecting processes is a problem. We self-select. It's true. That's a problem. We need math teachers who probably were trained in something other than just mathematics, so they have a broader scope. Sorry to interrupt, but
that's okay. I'll put
okay. I should. Can I ask? Are you finished?
Actually, let me go back to something. I think it was Kim that brought up the changing the subject here. Kim that brought up the comment about the labor-intensive and scalability of the mentoring process. And I was kind of curious about with Emory, since you've had a lot of experience with a large number of teachers that you have been working with, and I'm kind of wondering if you would have to rethink maybe the curriculum that you're working with them. Could you incorporate some lessons where they are where some of the advanced beginners, let's say, could be training some of the absolute very early beginners, so that in other words, take some of the load off of you and let them mentor the teachers that are coming along just behind them. I mean, that it seems like if you could make that work, it could pay off in a lot of ways. It would
You mean
save
train the trainers?
train, well, expect them all to be trainers. That's what I'm saying.
Yeah.
If you're going to be doing this, if I'm going to be training you, you're going to be training the next people coming down. Training them what you learned 3 months ago, let's say. Nothing dramatic, but it's going to help them solidify their own learning, and it's going to take the load off of you to be teaching over and over and over again the same early lessons to large numbers of people.
Shall I?
Okay. Go ahead and respond. I do want to get to Pinar. She's been waiting patiently. So why don't you go ahead and respond, and then we'll get to Pinar.
Okay, then very short answer. Well, actually, we are doing something similar because what I am doing is creating lesson plans with the teachers for the curriculum topics or units. And the units are not limitless. It's a limited number of, okay, maybe 10,000, and now we are in the first 100, but it is not unlimited. So when we finished a lesson plan, for heat transfer, or heat and temperature, for example, this is, when it is done, it is at that point very transferable. So that teacher with no support can just transfer that lesson plan to another teacher, and any other teacher that lectures that plan can transfer it to another one, because we do all the modeling, mostly using all the interfaces. We create all the worksheets, and they are available in the website. So when we do this, we do not redo that. If anything in science changes and heat and temperature starts to act differently, then we don't have to worry about them. So when we put something as a lesson plan, all we have to do is, if it is needed to be reviewed, or maybe it is changed from one year, one level to another, some minor outcome changes. So
okay.
Okay.
Thank you. Pinar, it's finally your turn.
Yeah, I waited too long. No, I'm kidding. Thank you guys so much. I learned, quite a lot about systems thinking, including this meeting. Just let me say that I'm a scientist. I have nothing to do with system thinking so far. I'm an evolutionary biologist. Now time to prepare some lectures. Then I try to put systems thinking while, conveying complex knowledges to the undergraduate students. Then I met Turkish group, then why I'm here today. I appreciate the conversations and I learned a lot. But I want to ask one question on how systems thinking in the classrooms while using that specific techniques to make students feel the data or get into it and learn better at these more efficiently, or also, comparable to real life. To me, it's still like a closed system. A classroom is a closed system. So again, everything is happening between teacher and the student. Of course, more, a better tools, like the platform softwares you shared and the techniques you use. So how open the systems thinking technique to the other expertises out of the class. So for example, my field is so convenient since I'm an evolutionary biologist. I can easily, work. In fact, I do with teachers do science education, ecology education, global warming, so on and so forth. So to me, it's an upper level of system thinking. The teachers use system thinking tools, plus open the classrooms, and the other people from the other systems can come in, and then we can make it more efficiently. So in which level in the models you use according to your experiences, say how possible is that? For example, Diana talked about the teachers need some encouragement and support to do so. So in which level those teachers, for example, ask help from people can help them better. So I am specifically asking how open this system from other world. As a scientist, for example, how can I approach the teachers to help better, or they help me to convey my message better? So how does it work? Any experiences, any suggestions? So how to make it?
Well, I don't want to discourage you. It is really difficult to break into a school to get access to a teacher. I have found that as a teacher, trying to go to other schools and talk to them, it's really hard to even break in.
Bureaucracy, you mean?
If you have, I think Emre, I asked Emre how he started. Heavens, he was an industrial engineer. How did he get to talk to teachers? Well, he said he had some teacher friends. And so I think that helped him at the beginning. And teachers talk to teachers, especially active teachers talking to other active teachers. I think it's important if it's your children, if you have children, of course you have access to your children's teachers. So the idea is, how do you even find teachers, let alone find a teacher who's willing to listen to you? Steve, go ahead.
Yeah, it's come up a couple of times here. There are teacher conferences all around the world. And I would say that if you went to one of those conferences and, attended some of the presentations that looked like they were about your topic and started talking to the teachers there about using systems thinking and system dynamics, that would be a great place to start.
I have to rely on personal interactions.
Yeah, my experience has been, as Diana says, from the inside out. I mean, the places that I've seen it be most successful are places where teachers have actually reached out because they're interested, and they try to bring professionals into the classroom. Going the other way, you have to go through all the layers of administration and everything, and that's what makes it difficult. But if you can get to the teachers, and I think the conferences are a good way to do that.
Yes, I agree. I think that's a great suggestion. Yep. So I know it's been an hour past. I don't know. Do you want to quit now? I would like for Emre to take 5 minutes to say how he has gotten to university professors who train teachers, just so we have it on the record. Would that be okay? Or should I just say we've done enough because we've talked a long time? Maybe we can have that conversation another time. Just tell me what you want. You want to quit? It's been a long time. Yeah, okay. You're not saying anything, which says to me, enough is enough. Let's call it a day. Okay. If you're interested, Emre and his group have done phenomenal work. They have 4 or 5 university professors who have brought systems thinking and some system dynamics into their teacher training programs. So they have been successful doing this. I'd say Turkey is like one state in the United States trying to affect change. They have a more unified, we have 50 desperate ideas on kind of what should happen in education in the United States. So, okay. Thank you for coming. It has been wonderful having you here. And I hope to see you again. Our next one is a SIG meeting next month to try to put a stock flow model together for peer bullying. That's our next month topic. Thank you for coming. See you later.
Thank you.
Take care, everybody. Bye-bye.
All right.